In today's class, we will learn the concept of recursion in brief. So far, we have seen many C functions in many programs, and among them, the function that we use in every C program is the main function. And in most of the C programs, the functions that we have used, we have seen are input output functions like scanf, printf. But all these functions are actually inbuilt functions, and we have seen other inbuilt functions as well in C. But there is a concept of function whose definition is not written in any header file. Rather, we define the functionality of that function. Means as per our requirement, we define that function, and accordingly we write the executable statements within or under that function. And in C programs, it generally happens that a function calls another function. Now in every C program, we know that we use main function, and from that main function we can call another function, which sometimes could be user defined function as well. And from that user defined function we may call another user defined function, and from that user defined function we may call another user defined function or another function. So that way, when we call a function from another function, and then from that function we call another function, and that way we continue, a process of chaining occurs. And recursion is a special type of that chaining process. Now what is recursion? Recursion is a process by which a function calls itself repeatedly until some specified condition is satisfied. Now suppose if we have a function, maybe inbuilt function, maybe a user defined function, say function 1, and if this function func1 or function 1 calls again this function function 1, and again that function calls again that function 1, means calls itself repeatedly unless there will be a condition, and when that condition will be satisfied, then that function calling will be stopped. And this concept of recursion we will be learning in a better way with an example little later. So recursion is used, we can say, for iterative or repetitive computations where each action is stated in terms of a previous result. Now as for the definition of recursion that we have learned just now, this example can be said as an example of recursion where we have used the main function, and then as per the normal rule we have this opening brace closing brace, and within this opening and closing brace or within this main function we have this executable statements. So first we have this inbuilt output function printf, and that will print this message, and then in the next line we have again this function main function. So main function is again calling the main function, and what will happen, so when it is calling main function, so control will come again here, and it will print this line of statement, and again it will call the main function. So again when it will call the main function, control again will come here and it will print this statement, and again it will come here, and this way it will continue till which point, till which moment, it will continue till infinity, because this process of calling or this process of execution will never end, because we have not specified any condition that where to stop. So this will never stop. That means two most important points of recursion is that the problem must be written in a recursive form. So a function will call itself repeatedly, iteratively, and the second and the most important point is the problem statement must include a stopping condition. Otherwise, it will continue infinitely. So this is a very important point that should be taken care of. And to incorporate that stopping condition in our function calling logic, definitely there will be a if statement to specify that condition of stopping and to force the function to return without the recursive call being executed. Means at the end there will be no recursive calling and the function calling will stop there, and whatever result we have accumulated or we have calculated so far, that will be given to us or that will be displayed. Now the simplest example that we learn when we talk about recursion is the program or the concept of factorial, or finding a factorial of an integer. Now here this is the program of finding factorial of an integer that I will explain. Here I have taken the input or the integer for which I want to find the factorial value, that value is 5, and we all of us know the how to find the factorial mathematically, and what is the factorial value of 5, and that output is 120, which is being produced from this program and is being displayed on the terminal here. Now we will learn the logic. So factorial 5, how it is calculated? This is the integer value for which we want to find the factorial. So first we write that number for which we want to find the factorial value, and then we multiply with the number which is less than 5, 1 less than 5, so it will be 4, and then that result of multiplication is multiplied with some other integer which is 1 less than 4, the previous value, so it will be 3, and then again by another integer which is less than 3, so it will be 2, and then by another integer which is less than 2, so that is 1, and this is the last number by which we multiply. So this is the end, the last value of finding factorial of any given number. Now if we multiply these 5 values, then the output or the result is 120. So that we know, that we all of us have learned in mathematics. But how to find that same factorial value programmatically or by using C programs? Now here in this program we have maintained the concept of function calling, function declaration, function definition, and the rule of data types, all these things that we already know. And in our program we have used printf, scanf, these input output functions, and that's why we have used this header file accordingly, standard input output. And this is the function declaration part. This is our function name fact, and that is for finding factorial. And this is the data type. Data type of what? The final result of that function, what value it will return. Data type of that final value means data type of the factorial value, and that could be sometimes very large, and that's why we have taken data type as long int instead of int or small int. And within parentheses we have mentioned the input, means for which we want to find the factorial value, and that input is n. So here input is n, and this is the function name fact. And definitely the input that we are providing to the program, maybe from the program itself, maybe from the terminal, that will also have some data type, and that data type, as I said, that is integer, so the data type is int. Now the main function, and as per the normal rule and syntax, rule of syntax, we have written everything, and here again we have declared the function, same declaration. Every executable statement is terminated by semicolon. These are comment lines. Then here we have printf, scanf, all these input output functions. In this printf function we are just displaying the message for which you want to find the factorial value. So this is just a instructional message. And then scanf, through this input function we are actually, from the terminal we are providing or inputting the value, the number, and that we are storing in this variable small n, and the normal rule of scanf function, and this is the format specifier. Since it was integer, so %d, and then again we have a printf function here, and what it is doing, we are printing here something factorial of n, and then we have mentioned the format specifier. That means we are displaying some value, but so far we have not calculated any value. Then which value we will display here? Directly we are finding the factorial value here. What we could have done is, before this printf function, or before we want to print the factorial final factorial value, we could have calculated that factorial value, and for which we are calling this function, and then we could have saved that final value in some variable, output variable, and that variable we could have mentioned here. But here we have skipped all those extra lines, and directly we are calculating the factorial value here, and here itself we are displaying the value. Now to calculate that factorial value, what we are doing here, we are calling that user defined function. So from the main function we are calling some user defined function. The definition of this function, which we have named as fact, that is not saved any of the header files in C, because what our requirement is and how we want this function to work, that we have to clearly mention through our executable statements. Now this is the end of the main function, and after the main function we have defined the user defined function fact, and we can define the user defined function before the main function as well. Now again here we have used the same declaration, and since this is a function, so within opening and closing braces we have written the main logic that how that function will work. So let's focus on the logic now. So control, when it will come to this printf function, it will find this, it will get this function calling, and then the control will come here where it has been defined. Then it will enter to within this function, and then it will get this if statement. So what is the condition? If n is less than equal to 1, but our n is what? The value of n is 5 that we have entered from the terminal. So in our case, now n is greater than 1. So it will come to the else part and it will return. It will try to return something. Return means it will return the output of that function calling. But what value it will return? And that logic we have within this opening and closing parenthesis. So let's focus on the calculation now. We have first n. So n means what is the value of n? The value of n is 5. And then we have this multiplication operator. So it will be multiplied by some other value. And what is that value? For finding or for getting that value, again it is calling the same function fact. So in the first call of that fact function, we have obtained this value 5, and now it has called the same function fact for second time, and then again the logic will come here in the if statement part, and it will check for the value of n. This time the value of n is 4, so it is more than 1, so it will come to the else part and it will return, it will try to return some value. And which value it will return? This time the value of n is not 5, this time the value of n is 4, that means 1 less. So in general if we think, then this time the value instead of n we have n minus 1. So which value it will return? Again within this opening and closing parenthesis, what formula we have, as per that formula it will try to calculate. So in place of n, now we have to think n minus 1. So n minus 1 or 4. So it will have 4 within the second factorial call or second function call. Now in place of n, it will have n minus 1. That means value wise if we think, it will have 4, and then multiplied by some other value. And what value? Again it will, for getting that value, it will call again the same function fact. So again the control will come here and we will have the same fact, that same function calling third time, and this time the value of n will be 3, 1 less, because it is calling the same function fact, but this time the input argument is 1 less. So initially if it was 5, then in the second function call it was 4, and in the second function call again when it is calling the same function fact, then within this fact now the input argument is 3. So again when control will come here, the value of n will be 3, so again directly it will come to the else part and it will try to return some value. So in place of 3, in place of n, now we will have the value 3, and that will be multiplied by some other value. So for that again it will call the same function fact, and this time n minus 1 means again fourth calling. So this time the value of n will be 2. So again it will skip the if part because it is still greater than 1. So it will come to the else part and it will try to return the value of that function call. And which value it will return? Now in place of n we will have 2, and that will be multiplied by some other value, and therefore that again it will call the same function but with 1 less value. So this time the value or the input argument for that function calling will be 1. So next function call, or this next fact function call, so now the input argument value is 1 and it will come to the if part, and this time the condition for this if statement will be true because this time n is equal to 1, and it will return 1 without calculating anything. The output of that function call will be 1, but where that output will be returned? To that place from where it was called. So now if we focus on this, the final value it returned is 1, and where it will return? It will return to that place where from it was called. So if we now go back, so now we are at the fifth function call, and fifth function call has returned 1 as output, and it will return to the place from where it was called. So here the value will be 1, and before that the value is 2. So this 2 will be multiplied, and then this 2 multiplied by 1, that value will be returned, and this is the result of this function call. And where it will be returned? It will be returned to the same place in this function call, previous function call. So this result of multiplication will be multiplied with the value that we have in the previous function call, because here in place of n we have 3. So this result will be multiplied with 3, and that result, whole result, again will be returned to the place from where it was called. So in place of this, now we can think of this result, and before that we have 4. So the whole result will be now multiplied with 4, and then again it will be returned to the place from where it was called. So this result now we have here, and before that we have 5, right? And this whole thing now will be multiplied with 5, and then the whole result will be returned. And now we are in the first function call, and then the whole thing that we have calculated as 120 here in the first function call, then that value will be returned, and that value will be returned to where? To that place where from it was called, the first function call. It was called from this place within that printf function. So now in place of this, now we have the value 120, and as per the syntax of printf, it will be displayed on the screen as 120, and that's what we have seen here. So this is how the user defined function calling works, especially the recursive call works. So I hope this class was meaningful for you. In our next class we will be learning something new. Till then, stay safe and stay healthy. Thank you.